Alright, this video is kind of a double video. It's got combining like terms and it also has distributive property. It's arguably probably the easiest video that we've got so far, but there are some tricky parts to it and some things that people kind of mess up on in general. Alright, so when you're combining like terms, the main thing is they have to be exactly the same terms. So we have x terms, and in this case we get no other terms. So when you're combining them, as long as they're exactly alike, not like one's got x squared and one's x to the third, they're both just x. You just count them up. So 15 plus 18 is 33, minus 2 would be 31, and there are 31 x's. Now things that people like to do with combining like terms that they're not supposed to. 2x plus 3x is 5x. It is not 5x squared. When you combine like terms, it's like you have 2 apples and 3 apples, and that makes 5 apples, not 5 apple pie, like it's just 5 apples. So don't mess with the exponent. 2x times 3x. It's better with parentheses around them. That would be 6x squared. So we'll talk about rules of exponents later on, but right now, when we combine like terms, we just add up the numbers and then we don't mess with the exponents. So here we have x terms, and then we have y terms. And then you're just going to combine them. So you have positive 12x, positive 10x, that makes 22x's. 5y and 2y would be 7y. Now, if they are different x's, then combine the x's and combine the x squareds. Box those x squareds. Now, usually you put the highest exponent first. So you got negative 2 and negative 7. You owe 2, you owe 7 more, that means you owe 9. And then your lonely x's, 3x and 15x, that would be 18x. So, it doesn't matter if they're plus or minus, you just put the minus in front of them. And in this one, we got an xy term, we got another xy term, we got an xz term, another xz term. Now in this case, the order doesn't matter too much. I would say x's come before y's, which come before z's. So x and y in the alphabet is better than x and z, so I'm going to put 4 minus 3, that's 1xy. And then 9 plus 10 is 19xz. Oh, 19xz. Now, do we need the 1? No. Does it hurt to have it there? No. Either answer is good. Alright, let's talk about distributive property. So the main part of the distributive property kind of looks like a little rainbow. You can distribute this 2 into both of them. Now, if you could do m plus 1, so for instance, if it was 2 times 3 plus 5, well, that's 2 times 8, like you would do the inside first. But in this case, n plus 1 is just n plus 1. It's not 1n. So you distribute, and you get 2n plus, and then 2 times 2 is 2. And then do the same thing with 3. So 3 times n is 3n, and I'm distributing a positive 3. So I'm distributing positive 3 times a positive 2 is 6. And then we combine our like terms. So 2n plus 3n is 5n. 2 plus 6 would be 8. And then we're good. Alright, I'll leave you to do B. Let's try C. That's a tough one. Alright, we distribute our 1/3. Now, you're multiplying by 1, and then you're dividing by 3. So 1 times 9 is 9. Divided by 3 is 3. And then you still have your x squared. 1 times 6 is 6. Divided by 3 is 2. So you basically multiply by the top and then divide by the bottom. So since the 1 doesn't matter, it's really 9 divided by 3 is 3. 6 divided by 3 is 2. Alright, and then let's see what else we got left over. So x squareds go together. 5x squared, negative 2x and negative 3x makes negative 5x. Oh, it's b squared here. So you don't mess with the exponents when you combine like terms, and they're both negative, they add up together. If they're both positive, they add up together. One's a plus, one's a minus, then they subtract. And I'll leave you with D as well. Let's try some later ones. Now let's do F. That looks like a trickier one. So we distribute the half into all 3 of them. Now remember, it's multiplying by 1, but that doesn't do anything. It's really just dividing by 2 part. So 1 times 2 is 2, divided by 2 is 1. Again, I don't really need to put it there. And it's really, what's a half of 2? Half of 2 is 1. Half of 2 is 1. But it's a minus, so a positive times a negative. So only one negative here makes a minus 1x. What's half of 1? Well, that's 1 half. 1 times 1 is 1. Divided by 2 is a half. Plus 2x squared plus 3. Alright, so what do we get? We got 1x squared plus 2x squared makes 3x squared. We have this 1x that doesn't have any like terms, so minus 1x. And then we get 3 1/2. Now we can write this a lot of different ways. We can turn this into a fraction, plus 3.5, which is probably the easiest way of doing this. The only thing is, the convention I want is if you have a fraction in the problem to start with, you should end with a fraction. But since we had a fraction right with a decimal, that's a problem. So what can you do? Now, as a mixed number, it might actually even be easier. 3 1/2, right? Okay, that's another answer. Actually, I'll take 3.5. I'll take 3 1/2. The other option is to turn this into a fraction. So this goes over 1, and then you want to combine like terms, so you need to make sure this has a common denominator. So multiply top and bottom by 2. So 3 times 2 is 6 over 2. 3 is 6 halves. So 1/2 plus 6 halves is 7 halves. Alright, let's show you something on that fancy calculator though. I'm going to show you how to do 1/2 plus 3, which you should know how to do since, like, what, 4th grade maybe? Alright, so let me show you. So we want to do 1/2 plus 3, right? So we're going to do 1 divided by 2 for 1/2. And then we're just going to plus 3. And we get that fancy 3.5 we got, which you also should realize is 3 1/2. Now, one of the fun things this calculator has is it'll take any decimal and turn it into a fraction. So how to do that? Hit this math button, which we're going to hit a lot. Hit math, and then the first thing we got is fraction. Hit enter, and hit enter one more time, and it'll turn it into the 7 halves that we got by hand. Alright, anytime you want to have fractions, just use the division bar. So let's say we want to do like 3/7 plus 2/8, which is really 1/4, but since I said it, it looks like really nasty fractions, right? Hit math, hit enter, you get that nasty decimal. Hit math, fraction, and it will tell you that it was 19/28, which hopefully you could do by yourself. Alright, big joke. Now, G is nowhere near as hard as H or I, but it's also the one problem on this whole page that more people are going to get wrong than anything else. I don't know how many times I get people to tell me it's x squared minus 4 or x squared plus 4. And both these answers are wrong. This is not correct. So what do we do? Well, you got to think about, what does squared mean? Squared means, so let's say we have negative 2 squared. That means negative 2 times negative 2, right? I have a negative 2 in here, so there should be a 4. And so for the people that thought plus 4 part, that's better. Still not right though. Something squared means itself times itself. So x minus 2 squared means x minus 2 times x minus 2. Alright, now what do we do? Well, we follow the distributive property. We're going to distribute the x into both. So x times x is x squared. X times negative 2 is negative 2x. And then we distribute the negative 2 into both. So negative 2 times x is negative 2x. Negative 2 times negative 2 makes a positive 4. There's our plus 4. The part that people miss is this middle part. It should be x squared minus 4x plus 4. And that is our answer. Alright, I'm going to start up h, but I'm going to have you finish that. Something squared is x plus 3y times an x plus 3y. Well, we haven't done, this is sometimes called foiling. I haven't done much of that, so I guess let's just do the problem. If you want to jump to the number I, you can always fast forward this. Alright, so distribute. X times x is x squared. X times 3y would be 3xy. And the order doesn't matter too much. As long as you have a 3, you have an x and a y. 3y times x would be 3xy. And then 3y times 3y would be 9y squared. Make sure it's not a 6y squared. there any other x squareds? No, so it's x squared. Is there any more xy's? Well, there's another one here. There's another one here. So we have 6 minus 2 makes 4. We get 9y squared and plus y squared, so that's 10y squared. And that's it. Always double check. Anything to add the x to? No. Anything to add the xy to? No. Anything for the y squared? We're done. That's the last problem for this. Alright, cube. That just means x plus 3 times x plus 3 times x plus 3. So we gotta distribute this all out, and you gotta be kind of careful with it. So what I would do is I usually go from right to left. Ignore this for now. That's x plus 3 is just kind of hanging out there. And we're going to distribute these two just like we did for the last couple problems. We're going to ignore this part entirely. So this part right here makes x squared plus 3x. And then we distribute the 3. 3x. And then we distribute 3 again. Now, some people want to distribute this right now. I'm going to leave this x plus 3 alone again. And we got to combine these like terms. So x squared plus 6x plus 9. Now we distribute this x plus 3 that's been out here the whole time. So this x gets distributed in all 3 terms. So that makes x cubed plus 6x squared plus 9x. You can multiply by x, it's nice because it's just x puts an extra x in all of these things. And now we're going to distribute the 3 into all of them. So 3x squared plus 18x plus 27. And then we look for our like terms. No more x cubed, so that's it. We have x squared here and x squared here, so 9x squared. 9x and 18x makes 27x. And then the 27 is just hanging out there. And so that's all she wrote. So, distributive property, the big thing to be careful about is this part. You gotta make sure you write that times itself. And then we distribute. And we should get 4 terms. 2 of them combine up, but do not just distribute your exponent in there. Especially when we get into the rules of exponents, a lot of times people want to apply those to these, and it doesn't really apply. You gotta rewrite it.